Assalamualaikum dear learner. This video is about the short questions of chapter number 3 exercise 3.1. Let's start. So question number 1 के 3 parts हैं और question number 1 के first part में further 5 parts हैं. तो this is the first part जिसमें आपने limit evaluate करनी है. तो just आपने क्या करना है, t को approach करना है t नोट पे और इसकी limit find करनी है. तो सिंपली जब आप t की जगह t नोट अप्लाई करेंगे तो ये बन जाएगा साइन स्क्वायर t नोट i प्लस टी स्क्वायर टी नोट j प्लस कोज टी नोट के. दिस इज आंसर. इसमें आपने लिमिट t को पाई असाइन करनी है. तो यहाँ पे इस पे जब अप्लाई करेंगे तो ये आ जाएगी 7 साइन पाई आई प्लस 3 कोज 2 t की जगह पाई j माइनस 9 के. उसके बाद यहाँ पे साइन पाई इज़ 0, so this will go to 0, and 3 cos 2 pi is 1 and sin pi is 0, so plus 3 cos 2 pi is 1 j minus 9k. The final answer will be 3j minus 9k. पार्ट नंबर सी में भी जो लिमिट है वो पाई पे दी गई है और इसको सेपरेटली आपने अप्लाई करना है सब फंक्शंस पे. कोस पाई जे प्लस 10 पाई के. अब सेकेंड पाई कोस पाई और 10 पाई की वैल्यू लगानी है. सेकेंड पाई इज़ -1 बिकॉज द सेकेंड पाई इज़ इनवर्स ऑफ कोज. so because cos is -1 at pi, so secant will be also be -1 at pi. 10 pi is 0, so putting values here you will get -1 times I plus -1 times j plus 0 times k vector, minus I minus j with the final answer. So पार्ट नंबर डी में आपने लिमिट अप्रोच करनी है 9 को. सो दिस इज़ 9i minus 2 9 square j plus 8 this square t, so this is square 9k. 9i minus 2 times 81 j plus 8 times 3k. तो 9i minus 162 j plus 8 3 times 24k. Answer. So applying separately the limit at t approaches to 0 in part E, you will get the answer sin t over t. This is sandwich theorem. As limit t approaches 0, sin t over t, this is 1. By using sandwich theorem, minus 2. Here limit put t equal to 0. 0 minus 1 j plus cos hyperbolic 0 k. This is I minus plus is 2j plus cos hyperbolic 0 is 1 k. So I plus 2j plus k is the answer. In part number 2 of question number 1, you have to find d by dt of a cross b. So first you will find a cross b, then find its derivative with respect to t. Finding a cross b using the determinant, separating the determinant components of determinant, that is I, j, minus j and k. Now cross multiply t square minus 2t plus 1 times 1 minus j, t square will multiply by t and so on. Now you see here that I have opened the brackets by using distributive law. 2t plus 1 multiplied by 2t minus 3, first with these two and second multiplied with these two as well. Also opening the bracket here and simplifying, adding and subtracting it and getting the final form like this. This is a cross b, and now you have to find the derivative with respect to t of a cross b. Applying derivative on each component separately, this is t square derivative is 2t minus 2t derivative is 2 minus 1 derivative is 0. Similarly, minus t cube minus 3t square minus 4 and this is 2t by power formula of derivative. 4t derivative is 4 and 3 derivative is 0 plus 3 t square derivative is 2t minus 3t derivative is 3 k. Now this is 4 2 times 8t. You can also write it as 2t minus 2i, and taking common minus here, this will be plus, and this will be 3t square minus minus plus 8t minus 4j plus 6t minus 3k. This is the final answer. In part number 3, you have to show that the vector A dot product with the derivative of vector A equals A magnitude derivative of A magnitude, where A is the magnitude of A vector, this is vector, and this is magnitude. To prove this property, you know that you can write A dot A vector equals A mod square. This is the property of dot self product. Now applying the derivative with respect to t on both sides, applying the product rule, first dot derivative of second plus second dot derivative of first equals power rule here 2a2 minus 1 dA over dt, the derivative of base further. This is a dot d over dt plus a dot d over dt. This will be 2 times a dot dA over dt equals 2a dA over dt. These are the magnitudes. Now 2 and 2 will be cancelled and you will get a dot dA over dt equals a dA over dt. Hence proved. This property means that if you take dot product of a vector with its derivative, it will be equal as if you take the magnitude of A with multiplied by the derivative of A. Thank you so much.